Hi everyone, welcome back to Array series. Hope you're doing good. This is Mahesh. In this video, we will solve Leetcode problem number 26, which is remove duplicates from sorted array. Okay, let us look into the statement of the problem. So given an integer array nums sorted in non-decreasing order, basically the numbers in the array will be in the increasing order which are sorted. Remove the duplicates in place. So this point we need to keep in mind. We need to do that in place such that each unique element appears only once. The relative order of the element should be kept the same. So this is also an important point we need to keep in mind. Then return the number of unique elements in nums. Okay, consider the number of unique elements of nums to be k. To get accepted, you need to do the following things. One is change the array nums such that first k elements of nums contain unique elements in the order they were present in nums initially. The remaining elements of nums are not important as well as the size of nums is not important. And we need to return the value of k here. So maybe, if you have already watched my previous video, this statement looks similar to the statement that we saw in the previous problem. So if you have not watched that, so that's a prerequisite for this particular video. So I will give in the description so that you can go to that video, watch that first and come back to this particular video. So they have given some examples, and if you see the constraints, the length of nums array ranges between 1 and 3 into 10 raised to 4. Okay, and the values in nums array will range between -100 to +100. Okay, and nums is sorted in non-decreasing order, which we have already seen. Let us try to switch to our editor and let us try to understand this problem. So now what they have given this particular array, correct, right? Now it means it is already a sorted array which is in increasing order, but it contains duplicate elements. As you see, 0, there are 1s, there is 2, there is 3, and there is no 4 in the array. So it means it contains duplicate numbers. So what we need to do, we need to remove these duplicates from the array. Then our result array will look something like this: 1, 2, 3 and 4, and remaining numbers whatever are there, then you can keep them as any number or you can keep them as underscore or empty number. So that really does not matter. Now what is the length of these unique numbers? It is 5, right? So k equal to 5. So this value we need to return. So if it was only this k value, our solution was getting validated, then we would have simply counted the unique numbers and we would have returned this particular 5. But that is not the case here. They will validate this value, and along with that, they will also validate this particular array. Okay, so they will check initial k numbers and they will validate against the unique numbers. And also one more thing what they have mentioned, which is an important point to note, we need to maintain the order of these numbers in the array. Okay, so this is the statement of the problem, and we have also seen the constraints. With that, maybe what you can do, you can pause for a second and you can think for any possible solution and you can come back. Okay, with that, now let us try to understand the idea or the intuition behind this problem. So before that, what I recommend, you better watch my previous and its previous video, which is remove elements and move zeros to end. These two problems are kind of same here, and we have already discussed the relation between move zeros and remove elements in remove elements video. So it is kind of continuation. So it is better, I recommend you go back and watch those two videos and then come back to this video so that it will be more easy for you to understand. Okay, with that, so in both the previous two videos, our interviewer was expecting us to solve the problem in O of n time complexity and O of 1 space complexity. So the same thing goes here as well. That's why I was trying to say, I mean, this problem correlates with previous two problems. With that, let us try to understand the brute force solution for this problem. So before understanding the brute force, maybe it is also a good idea to understand how this problem relates with the previous two problems. In move zeros to end problem, we were given 0 and we wanted to move this 0 towards end. Okay, so it means there was one particular constant value which they gave and that they wanted us to move at the end of the array, that to in place. Okay, next, remove element problem. Instead of one particular constant, they gave varying number, which is val. So they wanted us to remove or move that particular value to the end. So we somewhat use that logic. So they gave one varying value. So this is such variant. So this was one particular constant. This was one value which was varying. So they gave particular value, not a single constant value. Okay. Next, now if you see this remove duplicates, this problem, whatever we are solving now, this will contain multiple numbers, so which is changing continuously in a single array itself. Here the value was only 0. Here they gave one particular value, so that only one value was changing. But in this problem, the value continuously changes. Once it becomes 1, and next time it becomes 2, next time it becomes 3, something like that. So that is how, I mean, the variant is getting changed. So this is a good thing, I mean, what you need to observe in different problems that are given in the Leetcode. So with that, now let us take the array. So this is the given array. Then what is the extreme brute force solution for this particular problem? So now what we need all the unique numbers, right? So whenever we hear about unique numbers, what comes into mind? So set data structure, correct, right? Set data structure. So what is set data structure? It stores unique numbers into it. So we will simply take a set data structure. So I will simply consider this as our set data structure and I will check 0. So I will place it here. Basically, I will try to place all the values. So our set stores only unique values. So next time if I try to put 0, it won't store it. Next 1, it will store. Again 1, 1, it will ignore. Then it will store 2. Then next 2, it will ignore. Next it will take 3. Next 3, it will ignore. Next 4, it will take. And that way we processed our array. Okay. Now if you see, we have got our unique numbers. So now what I will do, I will replace these values in my original array. So my first value will be 0. Second value will be this one, that is 1, 2, 3 and 4. So basically 1, 2, 3 and 4. After that, these values will remain as it is. Okay. Now this array, our Leetcode compiler validates and we will return the length of this particular set, which is our k value, which is 5. So if I return the length of set, that is enough. So let us look into the pseudo code now. Now what I will do, I will take set equal to new set, something like this. Okay. Then I will say for I equal to 0, I less than n, I plus plus. Basically this n will be nums dot length. Okay. Now what I will say, set dot add, and I will simply say nums of I. Okay. So this is adding values to the set. Now once we do that, now what we need to do, we need to replace the values from the original array. So what I will do now, for I equal to 0, now I less than set dot size or length, set dot size or length. So this will give us the length of the set, and then I plus plus something like this. Then what I will do, I will say nums of I equal to set dot get of I. So this will give us the value in the set at ith index. Okay. So this is generic syntax I'm considering. You can consider the language specific syntax here. Since this is pseudocode, I'm considering this generic syntax. After this, our nums array got replaced with the values, right? The unique values. Now I will simply return set dot size. Okay. So now if you see, initially we built our set data structure here, then we moved the values from set to our original nums array, and then we simply returned our set dot size. That way, we will get our k. Now this will take O of n, and this will again take somewhere O of n, close to O of n, but not exactly O of n. It depends. If all the values are unique, then it will be O of n. That's why we can consider it as O of n. Then it is O of 1. So with that, if you see the time complexity for this solution, it is O of 2n. But if you see the space complexity, since we are using set data structure, it takes order of n time complexity. But in our solution, they have clearly mentioned we should not use extra space. Okay, we will see how to improve this. So this is the extreme brute force. Okay, now we used set data structure here. Is there any way to improve? Maybe let's see. Let us try to use a normal array instead of set. It is not really a better solution, but again it is going to use the extra space, but we will see that. Now what I will do, I will take the array. So this is, so now what I will do, I will take a result array. Okay, now I will simply put my first element into this result array. Why? Because always this element will be unique number, right? Because this is the first number in the array. So whatever numbers appear after that, they will be, they can be duplicate, but first value will always be unique. So now I will start from this particular index, which is 1. So if you see the index 2, 3, 4, 5, 6, 7, 8 and 9. Now if you see this index, this is 1. Now I can safely check my previous number. So if it has to be unique, if this particular number has to be unique, then it should not be equal to previous number, correct, right? Now you see 0, it is duplicate because 0 already exists, which is a previous number. Now if you see 1, this is not same as previous. That's why it is unique. So we will use that property. So now if this is same as previous number, I will ignore. Okay. Now I will move to next number. This is not same as previous number, so I will take it. Again, if I move to next number, it is same. I will ignore. I will move to next number. It is same as previous number, so I will ignore. Now this number is not same as the previous number, so I will take it. Now I will go to next number. Again, it is same as previous number. I will go to next number. It is different, so I will take it. Next, I will go to next number, which is same as previous number. Now I will go to this number, which is not same as previous number, so I will take it. Now if you see, I moved out of the array. So now this is our result array. It contains only unique elements and its length is 5, which gives the value of k. Now what I will do, after this, I will simply move these numbers back to the original array. This way, what we can do, we can get the unique numbers in the original array. Okay, let us look into the pseudocode. So now n equal to nums dot length. Okay, now I will take result array, which is a empty array, Now what I will do, I will iterate over this particular array. So for I equal to 1, but before that, what I will do, I will say result of 0 equal to nums of 0, because first number will always be unique. Now from I equal to 1, I less than n, I plus plus, what I will do? I will say if nums of I, if it is not equal to nums of I minus 1, its previous number, then what I will do? I will say result of, so here we also need an index, right, to iterate in the result array. So since I have utilized my 0 index, I will say index equal to 1 now. So I will say index equal to nums of I. Then after that I will increment my index. Okay, so this way I will place all the unique numbers into the results array. Then after that this is done. Now I will use one more for loop for I equal to 0, I less than, now this time result dot length I plus plus. Okay, then what I will do? I will simply say nums of I equal to result of I. This way I will copy my elements back to the nums array. Okay, then I will simply return result dot length. I can do this, or I can simply use this index. Okay, I can simply use this index to return index. Okay, so this way it will give us the value of k, which was 5 in this case, and also the modified array. Okay, the first 5 elements will be the unique elements. Again, if you see, we are using extra space. That's why our space complexity will still be O of n. And our time complexity is O of n for iterating first time, and again O of n. So somewhere it is close to O of 2n. We can simply write it as O of n. But if you see the space complexity, it is again O of n solution. So we don't want that, right? Now we want it to be in place. So maybe if you have gone through my 2 pointers introduction video, I have already explained you, whenever we come across such a situation where we want to improve this space complexity or boil down this space complexity from O of n to O of 1, then what we normally do, we use 2-pointer technique. We use 2-pointer technique. Okay, let us try to use that. So now we are using 2-pointer technique, 2 pointers method. So this is somewhat same as whatever the solution we have used in our previous video, that is move zeros to end or remove element. So there is a small change. So here also what we are trying to do, we are trying to move the elements towards left. So whatever unique number we get, that we try to move towards left. So let us try to do that. So what I will do, I will take my array again. I will put one pointer here and another pointer. Okay, so maybe what I will do, I will simply put the pointer here. I will start, one pointer on the 0th index and the next pointer starts from first index. Okay, now what I will do, I will check is my I will say this is red one is left pointer and this is right pointer. Is element at left pointer different than what is there now, because I'm starting here, right? No, it is same. So now what I will do, I will simply move to next index. Now one is different than the element at left index. So now what I will do, I will simply move my pointer to next and I will replace this value with this value. So I will put 1. Why I am doing this way? Because we have unique number at already the left index. Now its next index would be the place for the next unique number. So that's why we are trying to do this way. So before moving or before copying the number, what we do, we increment the left pointer, then we copy. So that way we will retain all the unique numbers. If we don't do that, we will lose this first initial unique number. Okay. So now with that, what we did, we copied 1 to the next unique place. Correct, right? Now I will move this pointer as well. Now I will check 1 again, same as whatever we have at the left pointer. So I will skip and I will move to next index. Again we got 1, so I will have to move next. Now if you see, we got 2. Correct, right? If that is the case, this is a unique number. So now what I will do, I will move this 2. Before that, I will move my left pointer here. Then at this particular point, I'll move this 2. So I'll move that 2 here. I will move my pointer to right. Again, I have 2, which is same as the element at left index. Okay. So now I will have to skip and I will have to move. So now I got a different number. So whenever we find unique number, that time what we need to do, we need to increment the left pointer and we need to place that number there. That's how we always keep the unique number at its right position. So now what I will do, I will move this pointer to right, then I will move my 3 here. Basically copy my 3 here. So now it is done. Next number is again 3, which is same. So I will skip and I will go to next number. Now I got 4. So it is different than what we have at the left index. So now what I will do, I will move the pointer to next number. Now I will move my 4 to this place. So this gets replaced with 4. Okay. Then what I will do, I will move next. So now if you see, we have completed our array, and if you see, we have the unique numbers here. Now if you see, our this particular red pointer is pointing at this particular 4 value. So this is at 4th index. Now what we need to do, to get the k value, we need to increment this by 1 and we need to return that value. So I will simply do left plus 1, then I will return this. This will give us the value of k, and if you see, we have modified this array in place. So we did not use any extra space. Okay. So with that, let us try to write the pseudocode. What we need a left pointer, correct, right? Which points at 0. Then we need a right pointer which starts from 1, So now after that, what I will do, I will use a while loop. While my right value is less than n, because that's what we did, right? I mean, we used this particular pointer, which is the right pointer, to travel or to traverse throughout the array. Once it moves out of the array, that time we stopped. So unless our right pointer is less than n, what we will do, we will check if nums at left pointer, if it is not equal to our nums at right pointer, then we found the unique number. So when we found, we need to do left plus plus, then we need to say nums of left equal to nums of right. Correct, right? If that is not the case, we simply incremented in the else part. What we did, we simply incremented our right pointer. So I will say right plus plus. Okay, so once we complete this particular while loop, once we come out of while loop, we need to return plus 1. So this gives us the value of k. Okay, now if you see, everything we did in linear time complexity, and if you see space complexity, it is of constant time, which is O of 1. So this is how we make the modification in place. Let us try to execute this code and see. So let us take value n equal to nums dot length. Okay. Then after that, what we need left pointer which points at 0th index. Then let right pointer be this should start from 1. Okay. Basically, it is not the start and end pointers. They are the pointers one after the other which moves towards the same direction. Okay. So now I will use a while loop. While my right is less than n, what I will do, I will check if my nums of left, if it is not equal to our nums of right, then we found the unique number. So I should say left plus plus, then nums of left equal to nums of right. Okay, so you can do plus plus here also. Instead of this plus plus, I will simply say something like nums of plus plus left equal to nums of right. So if that is not the case, then what we need to do, we need to we need to increment our right pointer so that we will skip that particular number. Okay, this we should do in both the condition. That's why I'm using right plus after the if statement. Now at the end we will simply return our left plus 1. Okay, with this let us try to run and see. It got accepted. I will submit it. Our solution got accepted successfully. Submitted successfully. Okay, so this is how we normally solve such related problems using the two-pointer technique. So you go through all the 3 videos and you try to observe how there is a slight variation between each problems. That's how we need to analyze the different problems rather than keeping the solution in mind, because sometimes we might forget the solution, but if we keep the logic behind it, then it becomes easier for us to answer in the interviews. Okay, hope you liked this explanation. If that is the case, please consider liking this video and also subscribe to my channel and share this video with your friends. And also if you have any problems that you want me to solve, you can add that as a comment. And if you have understood this explanation well, you can even comment that in the comment section. Thanks for watching the video.